Hello, everyone, and welcome to vCluster Fridays. My name is Sayam Pathak, and I work as a principal developer advocate at Loft Labs. This vCluster Fridays is a series that we do every Friday, and we try to learn about an open source project in the cloud native ecosystem. And today we'll be learning about kgateway. I'm very excited about this stream, and I have Christian and Lin with me from the kgateway side, and Fabian with me from the vCluster side. So the whole game is that we'll try to learn about kgateway in 1 hour, and we'll try to then install it, run it on a virtual cluster. So if you don't know about kgateway, if you don't know about virtual clusters, this is the right time to learn everything about that. So welcome, Lynn and Christian. Please kind of introduce yourself for a minute, then we can get started.
Awesome. I guess I'll go first. Hi, everybody. My name is Lin Sun. I'm a head of open source at Solo.io. I'm also a CNCF TOC member and also an ambassador. I'm a Istio maintainer, kgateway maintainer, and also kagent maintainer. Christian.
Hi, I'm Christian Posta, Global Field CTO at Solo.io. Yeah, I've been working on MCP and agents over the last year and a half or so. I'm very excited about what we're doing in the kgateway project to support those use cases. And yeah, I met Lin in the Istio community, been working in the Istio community, and just generally in a distributed systems space.
Awesome. Fabian, would you like to introduce yourself as well?
Sure. Thank you. Yeah, I'm Fabian. I'm a CTO and co-founder here at Loft Labs. Yeah, I'm primarily working on the vCluster technology, and also recently we launched vNode, where I was deeply involved with, and basically all the other open source projects we have as well. So yeah, very excited for today's stream and getting to know about kgateway.
Awesome. So again, nothing is prepared. Things can break. So don't expect everything to run very smoothly because none of us have prepared about what is going to happen next. I just know the flow, so we'll just try to learn and go with the flow. So first, what's happening? There was this vulnerability, NVIDIA Scape, which is very interesting. I would ask everyone to look at it, what it is. So basically, there was this container breakout that could happen using the container start hook of the NVIDIA container toolkit. So if you are running AI/ML workloads, if you are using the NVIDIA GPU operator, it has a component NVIDIA container toolkit. And if it's less than version v17.7, then you are kind of vulnerable to this particular attack. And what it does is it lets just in the with three lines of Docker file, it lets to run the environment variables on the host, and you can easily do the attack on the host. And this is where, like Fabian was mentioning, we have a product called vNode that lets you run this inside the virtual node. So even if you break out of the container, you never reach the host GPU. You only reach the boundaries of the virtual node. I dropped the video today. This blog came out this Monday that explains how you can actually reproduce the vulnerability end-to-end with a GPU-based Kubernetes cluster, installing the operator, and then creating the vulnerable file, and then doing that. So if you are a security fan, I think this would be kind of interesting to try out. Another thing that I saw, a repository about Carpenter has been famous. So this particular repo is Google Cloud Carpenter provider. So you can check that out. That is interesting as well. I don't know why it's not in the official auto scaling repo. Maybe it is coming over there, but I found this one, which maybe you want to check that out as well. Google also launched DRAnet in beta. So they went ahead and did the DRAnet in beta. It's basically from running their own AI/ML and high performance workloads that they have been doing within Google, and now they have open sourced it and made it in beta. It uses DRA, built on the DRA API, Dynamic Resource Allocation, which is part of the Kubernetes. And Kubernetes community has been actively working a lot on DRA. Then Docker is interestingly doing a lot in MCP. So Docker has its catalog where you can find the AI tool. I know Christian already knows all about MCP, so he can tell much better over here. But Docker has this toolkit where you can search for all the MCP servers, and you can easily configure them. For example, you can configure this, like if you want to configure Redis, you can just provide the configuration for Redis, and you can just add it. That's it. Like the configuration which is required automatically gets created. Also, there are clients. So it has different clients like Claude, Cursor, LM Studio. So you can easily connect, disconnect different clients, and they can talk to the MCP servers that are enabled using Docker Desktop. So it's pretty fancy. I like what Docker is doing in the AI space. I mean, using the same. That's what vCluster is also all about. Like, we want to, have the entire multi-tenancy spectrum using the same CLI and the same configurations. Similar to that, Docker wants to have the similar kind of developer experience for all your workloads, whether it's containers, whether it's WebAssembly, whether it's AI. And if you don't know, there is this landscape of cloud native AI. So this is a cloud native AI landscape that you can see. Especially, I like the model LLM observability. Some of the good projects are over here. And then you have CI/CD like Kubeflow, MLrun. So it's very interesting if you want like LLM, VLLM. I don't know if LLMD is there here or not. LLMD is by Red Hat right now. I don't know if it'll come on the landscape or not, but it's pretty interesting. So you can check that out as well. And then the Kubeflow introduced their trainer v2, again, for simplifying the AI model training. But whenever there is a major version upgrade, it means something, which is why they have a lot of things that they have done for this particular release. So those are the stuff that I thought about sharing because I have been reading about them. Now we kind of move towards what is vCluster. Fabian, you want to take what is vCluster?
Sure, thank you. So basically, vCluster is a technology where you can install Kubernetes into Kubernetes and not kind of as a kind way or K3S in itself. Instead, what we kind of use is a so-called syncer. That's essentially syncing from the virtual cluster that's installed in a host cluster. It syncs basically low-level resources such as pods, services, persistent volume claims to the host cluster. So basically, it creates a separate control plane, but it reuses kind of the data plane of the underlying cluster, and hence you can kind of partition a single Kubernetes cluster into multiple virtual ones, similar to how like a virtual machine partitions a single host machine into multiple virtual machines. So it's kind of the same analogy for a Kubernetes cluster. And the cool side effect of this is that now you can basically have a lot of different Kubernetes clusters with a lot of different access points for different tenants or users, essentially, for a single underlying host cluster, which then essentially results in much better utilization than if you were to create a lot of different separate Kubernetes cluster with their own separate reserved resources.
Awesome. So that's vCluster, and it has a very valid use case in the GPUs as well. For example, if you have a lot of GPUs and if you are having a bare metal and you have ordered some of the GPUs, then what you can do is you can have a single big host cluster that comprises of all the CPU and the GPU nodes, so that you can efficiently use all the bare metal resources. Because with this whole Gen AI wave, everyone wants their data closer to them. Everyone wants their secure data closer to them for their applications, which is why people are building their mini data centers and are doing, and obviously they want to use Kubernetes. But when you create multiple Kubernetes clusters, because obviously there'll be multiple teams who would be working on different sets of your AI/ML workloads and would be needing different Kubernetes clusters. So it doesn't make sense if you create multiple Kubernetes clusters and divide those physical machines. You'll be out of resources very soon, because even a minimalistic cluster will be having one node for control plane and 2 nodes for your worker nodes, even if it's not HA. So if you have 10 different clusters, then you can imagine you already have 30 hardware devices that you already need to create those. So with that, we say like have a single host cluster with everything in place, and then create virtual clusters as many you want based on the capacity of the host cluster, and then distribute them to the different teams. All right, that's vCluster. But yeah, if you have any questions, queries, feel free to put that in the comments and chat. So yeah, that was my part, Lin and Christian. Now we want to learn more about kgateway. So let's start with like, what is kgateway?
Yeah, I guess I'll start first. So kgateway is our Glue project. We started Glue, I guess, 2018 or 2017, before I even joined Solo. I think, Christian, before you even joined Solo. So it was our Envoy-powered Kubernetes native API gateway. And last year, we took Glue to CNCF. If you go to I think it was at KubeCon Salt Lake City, we actually donated Glue as a CNCF project and called it kgateway. So that's what the name kgateway was born at Salt Lake City. So in a nutshell, it's basically a gateway, API gateway using Envoy as a proxy. It can be your ingress. It can be your advanced API gateway. It can be served as a waypoint proxy for Istio Ambient. It can be an AI gateway. Actually, Christian, I think you are more familiar on the AI side. I'll probably pass to you to talk about some of the exciting work we're doing on the AI side. So all I want to say is it's a vendor neutral project in CNCF as a sandbox, and we're hoping to move to incubation very soon. And it's very battle tested with a lot of expertise working with hundreds of customers, and some of the customers running very, very large scale. So we recently done a performance test. I also put a link in there, so you can check out the kgateway control plane performance is really well in terms of CPU, memory, latency, and everything. I'd like to pass the mic to talk to Christian to talk about the AI stuff we're doing in kgateway, which is really exciting as well.
Yeah, absolutely. So in kgateway, what you're going to see is that we support the LLM gateway pattern, which is a gateway that sits between your applications and the LLM. So AI gateway, and with that gateway there, we can do things like enforce guardrails. We can enforce things like failover and rate limiting, and even doing things like RAG and caching and so on. So the gateway, the LLM gateway pattern is extremely powerful for people using LLMs, and gives you control and security around that usage. The second thing that we're doing with the gateway is inference gateway. And so what this means is, especially on Kubernetes, when you're running your own models, for example, with vLLM, hosting on your own GPUs, we can use kgateway to make smart inference routing decisions, because those VLLMs, those LLMs running in your infrastructure, they run differently than APIs do. APIs take a request and they respond very quickly. Usually, LLMs, they might take forever to respond. And so you might end up with work queues for those LLMs building up. The GPUs might be loaded, or maybe not. And so what we can do with the inference gateway pattern is pull information about the GPUs, their KV caches, their adapters that have been loaded, the work queue depths, and that kind of stuff, and make routing decisions based on that. And actually, the LLMD project uses kgateway as the routing gateway for inference. So those two are very powerful, important capabilities. And the last and certainly not least is the support for things like MCP and A2A. Those protocols are stateful protocols. Again, they're not like REST protocols. Those protocols can implement bi-directional initiation of the requests. And they have some evolving capabilities around security, which kgateway can help standardize things like OAuth and API keys and that kind of stuff. So kgateway is an exciting project. Now, the interesting twist that you'll see is that kgateway, as a gateway, uses an Envoy-based data plane, but for the AI use cases, we'll use a Rust-based data plane. And so there's, Envoy project is fairly well known. We released the Agent Gateway project maybe about 5 months ago now, which is picking up a lot of steam, a lot of adoption. If you take a look, Lin, if you go to Agent Gateway just real quick, that'll be the underlying.
I put the link in the comment if you want.
Oh, perfect. Okay. Yeah. That'll be the underlying data plane for the AI capabilities. But from a user's perspective, you have kgateway and the API for kgateway. The underlying proxies that run will be administered by kgateway.
Yeah, so in a nutshell, kgateway is passing Kubernetes gateway conformance tests for both Envoy-based and also Agent gateway Rust-based proxy.
Right.
And also the Kubernetes gateway inference gateway, which has a conformance test coming up, and kgateway will pass both either data plane option too. So we're very, very excited about this. So let's get it working, I guess, in vCluster.
Yeah.
That sounds great.
Yes,
Unless there's any questions we should take.
Yeah, just one thing.
Questions.
Maybe I would say just one thing. If we can, explain a bit about, let's say, people coming in from a very beginner perspective and they don't know what kgateway is, what we are talking about over here. So let's say you have a Kubernetes cluster and you create a deployment, and then you create a service, and then you want to expose that to the outside world. Usually people have been creating ingress. So then for those people, if you have to explain what this project is, how would you explain that?
Yeah, so I would explain as gateway serves as like a door into your house, right? Imagine your house is your Kubernetes cluster, and gateway controls the traffic coming into your house and the traffic goes out of the house, which you have to exit through some type of door, right? Whether it's ingress or egress. So before we started a gateway API in the Kubernetes community, people using the ingress API to programming that traffic coming into your house. But now Kubernetes Gateway API is the future of networking API in Kubernetes. So everybody is busy adopting the Gateway API. So it's the kgateway project as well. So yeah, if you check out the implementations, you can see kgateway is listed there twice, because one is with the Agent Gateway, the other one is the Envoy-based proxy in kgateway.
Interesting. Just like for my understanding, like what makes the Agent Gateway kind of like different from the Envoy proxy, or like why is there a need for the kind of like Rust-based proxy?
I think there's two main reasons. One is the AI space is changing very quickly, as you know. The protocols there are hopefully stabilizing, but we don't know, and they're continuing to evolve. And so the first is for speed. We need to be able to keep up with what's happening in the AI space. And Envoy, Nginx, some of these older proxies are very stable. They don't take change lightly, let's just say. So that's one aspect. But then the second is, Envoy is extremely versatile. You can do a lot with it, and it's very pluggable. And we built our first generation of AI gateway on top of Envoy, but we were running into limitations, might not be the right word, but we were running into things that were awkward. Envoy wasn't built for these stateful type protocols. And like I said, especially one use case that's very popular for or necessary for our users, the customers, is that of what we're calling an virtual MCP server, right? So where you might have, say, 10 MCP servers that you want to proxy, but you're not proxying them straight through. What you want to do is for a particular client, say, hey, you have access to some subset of tools across some subset of MCP servers, right? So you want to multiplex them. And those types of use cases would be very difficult to pull off in Envoy without a lot of changes. And so we decided that although Envoy is great, if you're doing microservices, API gateways, all that stuff is amazing, but to pull off these protocols is not natural, let's say, in Envoy proxy. A lot of changes will have to go into it. And you do see some people trying to work upstream to do that, but we feel in our, we're deep Envoy experts. We understand Envoy in and out, been contributing into it for 8 years or something, that this, for AI use cases, the ones that I discussed in kgateway, that it's better to implement those right now in Rust.
That makes sense. And so basically the kgateway version with Envoy you recommend for like regular API use cases, and the kgateway version with the agent gateway for these AI LLM use cases.
Yep.
That makes sense.
Yep, exactly.
Yeah, for now, longer term though, when the Rust-based, which is agent gateway, does support the traditional gateway feature too. So longer term, as that code being used and adopted, we may see people moving to there as well. So I actually have a story to tell, just to add on to what Christian said. So when we started the Ambient project 3 years ago, we actually wrote, if you're familiar with Istio Ambient, right? We had a lightweight layer 4 proxy, and we had a layer 7 proxy. So when we initially started with Ambient, the layer 4 proxy was programmed using Envoy proxy, same as the layer 7 proxy as Sidecar. And what we find out is that there was literally like 2 people on the project and troubleshooting that layer 4 proxy because it's super complex. It has to do different things for multi-tenancy, even just layer 4 traffic. It has to handle traffic encryption, HBOM, and then 6 months later, after the project, we decided, this is not scalable if only 2 people can troubleshoot what's going wrong. So we decided to rewrite everything from scratch using Rust. So, and that turned out to be a hugely successful. Istio Ambient has been adopted by many organizations, some organizations running at very large scale. So we took that lesson we learned in Istio Ambient, and part of the similar contributor like John Howard, reuse portions of code to the agent gateway. So we're not building exactly agent gateway from scratch. It's actually built on to 3 years of expertise we had building Istio Ambient, and learned all the things we couldn't easily do with Envoy, and all the complexity of, programming Envoy to do what we wanted to do. So add back to what Christian said, to work with MCP and A2A. So that's why we actually decided to not using Envoy and reinvent the wheel with Rust.
That's great. That sounds very exciting. Yeah, we used also some ambient mode recently.
Oh, cool.
Customers have used it, and we integrate with vCluster with it. And it's really cool. Yeah, it's so much easier than the sidecar-based version.
Yeah, so happy to hear that. Thanks for that feedback.
Yeah, no, definitely. That's a really, really big improvement for Istio.
Yeah, thanks. I know it still works on vCluster, and I've seen demo. I think I might run that myself before.
Yeah, you can install basically so we have kind of 2 versions of it. So either you install and there only the sidecar-based version works inside the vCluster. But what actually most people want is like one Istio installation that you can then reuse in vClusters, and that only works with ambient because it's more on the lower level. And yeah, we have this Istio integration that Sayam is showing here.
Well, shout out to your team. You already added the ambient integration. Nice.
Yeah, and ambient mode is really great for that. Like it really works nice with that.
Awesome.
So maybe just one other question, if that's okay. So how is the relation between Agent Gateway and the kgateway project? Is Agent Gateway kind of also meant as a standalone project, or is it really purposely built for kgateway?
It's the same relationship that Envoy Proxy has with kgateway, which is it is a data plane. It is a standalone project. You know, both of them are. It can be configured standalone. But when we bring it to Kubernetes, that's where kgateway comes into it. Kgateway ends up being the control plane you can think of for these data planes.
That's cool.
So if you're
the proxy as well.
Yeah, so if you're a user using Kubernetes, we would recommend you to consume Agent Gateway through kgateway, right? Because it's supposed the Kubernetes API to allow you to programmably program Agent Gateway. But if you're a user outside of Kubernetes and you can configure your own configuration file fit to Agent Gateway, so you can run it very easily outside of Kubernetes, so you don't have to have a control plane to program that. So that's when Agent Gateway comes in without kgateway. By the way, we actually going to took Agent Gateway also to vendor neutral foundation. So we're very excited. We just had our first community meeting yesterday. There was people from very large organizations like Cisco, IBM, Red Hat, AWS, Microsoft all joined us to discuss like a project status update and roadmap. Yeah, a lot of excitement in the community around Agent Gateway.
Yeah, that's amazing. Yeah, I also saw like LLMD was like publicly announced, very widespread from I think even Google or.
Red Hat, yeah. So Red Hat started LMD.
Yeah, so like that was also a really big announcement. So really, yeah, very cool to see this is using kgateway as well.
Yeah, we were so excited. It uses, I believe, 3 inference gateway, and the only 2 are open source, which is kgateway and the Istio gateway, which you
I don't know. Is the Istio one even merged in? That was on a branch.
It was on a branch when it announced, but it just merged like a week ago. Okay. Yeah, but either project, I think Solo is like the #1 contributor for either of the project. Amazing. Yeah, and the third implementation is I think it's GKE, which I don't believe is open source. So.
It's amazing. Yeah, sounds really interesting. Yeah, we definitely need to play on our side as well more with that. Because very interesting.
Yeah, I think they have a test model. You might be able to get it running even with vCluster with the test model.
Probably, yeah.
I mean, the inference gateway, I'm not sure about LLMD. LLMD, I think it's more complex to run than the inference gateway. I would recommend
sure if we can set that up now on the
would recommend you start with the inference gateway first.
Yeah.
Cool. So what we'll do now is we'll try to run kgateway on vCluster. Let me share my screen again. This time I want to share the terminal. I need to find the terminal. Where is it? So just give me a second. All right, there you go. Cool. So let's see how stuff works. Give serial, get nodes. I have a Kubernetes cluster which is running. I have vCluster also running. So what we'll do is we'll simply create, I don't know if I have, let me just first run this. Cool. And now we'll do vCluster, create kgateway.
So that's create a dedicated vCluster named the kgateway?
Yes. So what it does is
Okay.
it creates, since we haven't provided any, I mean, kgateway is just the name given because I wanted to create kgateway. I can give any name, and I can also specify the namespace. Since I didn't specify any namespace, it automatically creates a namespace by appending kgateway, whatever the name that you specify over here, with a vCluster prefix. So it will create a namespace called vCluster gateway. What will happen now is that in this particular namespace, there will be a stateful set that will be spinned up. That stateful set is having a pod, which is the control plane. So that stateful set is actually the control plane of this particular virtual cluster. That is, correct me if I'm wrong, Fabian. So right now it is a single process which is there that runs the control plane, right? And has all the components that we define, like the controller manager, embedded SQLite, and then you have the syncer component. So everything is there, very lightweight, that runs as a single pod. And all the interactions now, if I do kubectl get nodes, now I won't be able to see the host cluster. I'm inside the virtual cluster. So with every virtual cluster, it creates a kubeconfig file. Right now, since I didn't specify any flags, kept it very simple, what it did was it used my existing kubeconfig file and added a new virtual cluster context. So if I do kubectl config get context, you can see the vCluster gateway context was added, and it automatically switched to that. So now I am inside the virtual Kubernetes cluster. Now, when you hand it over to anyone, for them, it is a CNCF certified virtual, like CNCF certified Kubernetes cluster, conformant, passing all the conformant testing and all that stuff. But as a Kubernetes admin, like if you are the admin who have created the host cluster, you know that how many virtual clusters will be there, because in the end, they are running in the namespace. So that's how it is. So what we'll do is I have a quick start, and I can actually share the screen if that helps, so that you know what I'm trying to do, and you can share what needs to be done. Okay. So now you should be able to see everything. So I should be going to the getting started, right?
Yes, I would recommend that. So the first step, probably just install the customer resource.
Okay. So this is the custom resource.
So we have two
definition.
sets of the customer resource. One is the Kubernetes Gateway API. I think right now we're using 121, 130 should work too, which is the latest. And then the second one is the kgateway builds Kubernetes Gateway extensions on top of Kubernetes Gateway API. So if you are familiar with Kubernetes Gateway API, you know it's like the standards for future of Kubernetes networking API. And what's interesting about this API is it allows users to build extensions on top of that. So kgateway build some extension for like allow people to configure access log, allow people to configure rate limiting through a traffic policy. So these are through extensions, which is what we need to install also for some of the a little bit more sophisticated user cases in kgateway to work.
So let's do the kgateway CRDs. And I'll copy this in the meanwhile.
Yeah, so that's install the latest stable release of the kgateway project.
Okay,
Yeah, so this actually shows you which ones are coming from Kubernetes and which one the kgateway.dev are the specific extension built by the kgateway project.
Okay, traffic policies, listeners, gateway parameters, extensions. Cool.
So what's getting deployed is the kgateway control plane. In order for a user to stand up a proxy, like an Envoy proxy, to control the incoming and outgoing traffic, that's using the gateway API to deploy a gateway resource. So by default, the control plane is there, but up to the user, based on the user cases, you can determine, how many gateway you need to deploy and how you want to control the traffic through like route configuration.
Okay. So the pod is running. We should be able to go to the next steps, right?
Yes, absolutely.
So this is the one that we should try.
Yeah,
Sample
so
app.
this one is like a really simple one. Yeah, HTTP Bing, and then you config route the traffic from your ingress gateway, which is kgateway proxy to the Edge sample app.
Okay.
You have very loud keyboards.
Yes.
That's probably Fabian. Yeah.
Oh, it's yours. Okay. Sorry.
Yeah, this muting and unmuting myself is always.
All right. So we have this. Get SVC. And that's the SVC, which is there. What else was there? Service account. Okay.
So now we have the classical Kubernetes problem, right? You have a service. How do you expose your service to anything outside of the Kubernetes cluster, right? How are you going to access it? That's the front door problem we talked about earlier. Yeah.
So what do we do next? We set up a gateway.
Yeah, so you set up a gateway. In this case, it's an ingress gateway to control traffic incoming into your HTTP Bing or any other app in your cluster, right? And then to deploy a kgateway, you basically using the Kubernetes gateway API, but the only thing is the gateway class name, you program it as kgateway so that the kgateway control plane knows, oh, this is a gateway class that I need to act on, which I need to deploy the Envoy proxy and manage it for the user.
And what is the listener over here?
So in this case, the listener means when the user access this gateway proxy, which is going to be stand up by the control plane as a deployment and services. When the traffic reaches on the port 8080 or 8000? Okay, thank you.
8080.
When the traffic reaches 8080, I'm going to allow HTTP route configuration from all the namespace to programmably configure what's next. So, assuming you may have routes configuration attached to this gateway to instruct where the traffic goes next. So basically just having this gateway resource would stand up the deployment, open up the listening ports, but the gateway would not know where to go to the traffic unless you have a corresponding route configuration.
So when we installed the kgateway, it automatically installed the gateway classes for us. So
yes.
Okay.
So
And
that's
as
the customer, I believe that's as part of the installation. So remember, you install the customer resource first,
yes,
and then you
yes.
install the K-gateway control plane. Yes. So right now, if you check your deployments, you should have a gateway proxy, K-gateway proxy, or something called that in the K-gateway system namespace. So it's called HTTP. That's right, because the name here, we called it HTTP. So whatever name you gave to the user gave, we're going to send up an Envoy proxy based on that name in your gateway resource.
Okay. So we have the gateway class that was created. We created the gateway. And
Yes.
as we created the gateway, the K gateway realized that it is there. It creates a envoy proxy for whatever the name that we define for that particular gateway.
Right. So now we have to figure out two things before we can access the app. So the first thing is when the traffic goes to 8080, how we're going to route the traffic. The second thing is how am I going to access this gateway, right? So typically you access either through load balancer IP, or you access through port forwarding, or you access through no port.
Yeah, it has the LB.
Oh, nice. So that's provided by vCluster automatically?
No, that's provided by the cloud provider under the
Cloud
hood. So
provider.
vCluster just syncs it from within the vCluster to the host cluster, and then the host cluster assigns basically the load balancer.
Nice. So may I ask, where are you running your Kubernetes cluster? Sorry.
Yeah, that's what I was going to ask.
Oh, this
It
one,
must be
this
GKE.
one. No, this one is DigitalOcean. Keeping the cost low.
Okay, cool.
And, yeah.
Where does it run?
DigitalOcean?
Oh, DigitalOcean. Oh, yeah. Okay, cool. Yeah.
Yeah, very cool, because this is a better experience than my local laptop.
So will it have the address like?
Yeah, so you have the address, but when you hit the address, it doesn't know what to do, right? Because
Okay.
I don't think you have a route configuration. Remember we explained when you stand up the Envoy proxy, you said, I want to open up 8080 to listening on that port. But as far as what to do, I rely on the route configuration, and the configuration can come from all the namespaces. So the next thing you have to do, if it's HTTP traffic, you have to kind of create a HTTP route resource and then deploy that resource to your cluster in a namespace. So which is what this is showing, right? So this is a HTTP route configuration. It says when the traffic goes to this particular gateway, which you can see the parent ref refers to the namespace of the gateway along with the name of the gateway, which is HTTP here, and then it specifies a host name. And then the rule, which is important, of when the routes goes to the gateway, it routes to the backend, which is the HTTP 88,000 or maybe, or 8080, sorry. I feel like I'm aging. I can't even see the number very well.
No,
Okay.
this one is 8,000.
Okay, it is 8,000. And the other thing I want to say very importantly here is notice the namespace where deploy the HTTP route is in the HTTP namespace, right? So because that's where the HTTP being runs, so when you specify your backend ref, you don't have to specify the namespace again, because by default, it can allows to route to the backend within the same namespace.
Route. So since we don't have the example.com, can we use any wildcard stuff?
I think you can definitely use the wildcard. I would say having the example.com shouldn't hurt you, I hope. But wildcard should also work.
Like, can we use this.xip.io or nip.io?
I don't think you need to specify that. Actually, I would say it's not a good practice to specify the IP address, because what if you get a different external IP? You don't want to go back and change your HTTP routes, right? So I would do star or just leave it as example.com.
Like this?
I don't remember if we need a quotes on there. Let me double check. But we should give you status, by the way. So should be fine if it's not correct. If it's not correct, we should give you some error messages. Yeah, what I wasn't sure if we need a quote around the star. Okay, I guess it's complaining, invalid value. Okay, so try to put, oh, you did put quotes. Okay, I would put example.com, whatever in the example. Because by the way, it's not a good practice to use star in the gateway or route configuration because
Yes.
the security issues. Oh, somebody was asking a question about kgateway was Envoy gateway, which we can talk about that when it's the right time. All right, so this, by the way, yeah, you can do a status checking. It's in the HTTP namespace. So a good practice right now is actually to do dump out, the resource and check the status. It's important to make sure it's accepted, and if it's not, it typically would give you a good reason on why. So we do have nice validation, as you can see, right? The host name, it failed, and also give very good hints to the user regarding status of the routes. Now you should be able to hopefully access your HTTP application now because everything is looking good. Yeah, so this example should work because you have a load balancer IP. So yep. That looks right. I think that was your IP. Yeah. I think it's working. So basically, yeah, we showed how the traffic reach out to the HTTP being gateway proxy, which is running in the kgateway system and listens on port 8080. And we successfully programmed the HTTP route to configure the route to go to the HTTP being as the backend on port 8000.
So what's the flow that happens? Like, how does the request flows in?
Yeah, so the request would goes to the HTTP being Envoy proxy, which is running in the kgateway system, right? So, and then that Envoy proxy would be programmably configured to know how the traffic should route to when the traffic arrives on 8080, because the control plane watches the HTTP routes configuration by the kgateway control plane, also in the kgateway system, and automatically program the Envoy proxy, the HTTP being Envoy proxy, to do the route configuration. So the Envoy configuration, we didn't dump it here, but it's intelligently programmed to know what to do when the traffic arrives on that 8080 port number for HTTP traffic and where to route next. So that's magic is all done by the kgateway control plane. From a user perspective, user just feeds the HTTP route configuration, which you deploy to your vCluster, right? It's very, very simple. It's human readable. But I bet you the Envoy configuration is probably more than 100 lines. It's going to be way more complex. That's the job of the kgateway control plane to it's kind of like providing you nice UX between a simple Kubernetes gateway API to translate that to Envoy complex configuration for you. I saw a question coming. Should we take the question, or should we continue to explore a little bit more on the vCluster side of kgateway integration?
Yeah, just one more thing, and we can just do that. So let's say there is another application that we want to kind of deploy. Yep. So then we don't need to create the gateway. We only need to create the route, right?
That's right. If your other application, you choose to share the same gateway proxy, you can just configure it using the same. There are reasons you may choose, you want a dedicated gateway proxy for your application. If your application is like a critical, you don't want to share with other projects or other team, then you may need to have your dedicated gateway proxy for you. But the share one is a common user case.
Okay, because even in the gateway API, it's defined like this is something that comes with when you install kgateway. This is something that is done by the operators, and when you are the application developers, you just create the routes, right?
That's right. Yeah, the cluster operator normally is the one in charge of how many gateway resources I'm going to deploy and I'm going to provide to my team. That's why if you recall in the gateway resources, you specify which namespace you can attach route to this gateway resource, right? Remember we had a allowed routes configuration, and I think we had it as all namespace in our example. So that means, yeah, right here, that means every single namespace in the cluster are allowed to attach routes to this gateway resource. But as a cluster operator, you can also say, you know, I only want these 5 teams to attach routes to this gateway resource, and the other 10 teams, I want them to use a different gateway resource. So the flexibility is provided to the cluster operator for these type of scenarios, and how you want to carve out your Kubernetes cluster to your desired way.
Nice. Cool. Yeah, we can take the question as well.
So kgateway was Envoy gateway. I guess I can take my step. Christian, you probably have your opinion too. I would say Envoy gateway is slightly newer, has a little bit less history than kgateway and Glue. First of all, Glue was started, I think I mentioned, almost 9 years ago. Created by Solo initially. It was an open source project, so it has been, we've been working with large customers, and have multiple evolution of the control plane to make sure, you know, it's highly scalable, adapt to large customer user scenario. What I do believe kgateway really shine is it handles it performs really well, the control plane, when there are route changes, when there are routes, deletes, and updates. So we've done a bunch of testing with that. So that's number one. It's the scalability. I do think kgateway definitely shine. Partly also because we took the experience, we work with all the users and adopters and the customers and build that into kgateway. Number 2, I would say, is Envoy Gateway. It's kind of a project inside of Envoy, where kgateway is its own project. So the governance model is definitely a little bit different in that case, because Envoy itself is a graduated project. And when the community took Envoy as a graduated project, I don't believe Envoy Gateway existed back then. So don't simply think about Envoy Gateway is also a graduated project, because the graduated project was the Envoy itself. They are similar in a sense, both as implements Kubernetes Gateway API. I think both also implements the inference gateway, because I believe Envoy Gateway recently also added the inference gateway capability. I would say kgateway probably shines more on the AI work, where we have support for MCP gateway, and also the agent gateway integration is coming in soon. Christian, what's your take on this? I'm curious now.
I mean, you covered it pretty comprehensively, Lin. I mean, I think that the 2 takeaways for me are that around scalability and maturity. And I mean, you hit on that, so I don't need to belabor it.
Yeah, I guess the other thing probably worth mentioning, I know you probably briefly shared that, is John Howard is a very respected community member in major contributor, #1 contributor to Istio project and major contributor to Envoy and many other projects. I believe he's actually the #1 contributor for all the CNCF projects combined. So, and he ran a gateway API benchmark test, which you showed briefly, and it actually shows where each project, the strengths and weakness of each project. So I don't want to repeat that, but you can see where John highlighted on the thing. Actually, if I can share my screen quickly. Let me see. Sorry, let me figure out how to do screen sharing. Let me share my screen, because I think it's more convincing to share the screen than just talking. All right, so yeah, so this is a summary of finding. Obviously, there's way more detail than the detailed finding. If you're interested in all the details, it's all here. But the summary of finding, I thought it's worthwhile highlight is you can see Envoy Gateway and kgateway is right here, along with Kong and Cilium. And I actually did some validation myself even before John published this test between on kgateway. So I know I was able to deploy like 10,000 routes and then change one routes and be able to delete one routes with like 10,000 routes in my cluster, and kgateway handles really, really well. And I only have to wait until like seconds for the new routes, whether it's modified routes or delete routes or addition of the routes to come in effective. And you can see Envoy Gateway didn't perform very well with errors, memory leaks, and you know, from an architecture point perspective, we do believe Istio and kgateway has a better architecture from a control plane perspective because it handles the changes coming into the control plane, right? In the example, we kind of showed a really, really simple HTTP routes deploy into the Kubernetes cluster. But imagine a large customer scenario, you're not going to have one routes, right? Your gateway typically serves thousands of routes. So when you already have 1,000 routes, what if another team wants to come in and maybe make a modification to an existing route or add to a new route? So that's when the control plane architecture becomes important, because it's critical for that control plane to be able to not recalculate all the existing endpoints, all the existing services out there, and be efficient on what's needed to, what configuration needs to push to the Envoy proxy. And this is where kgateway and Istio really shine if you look at the test results. But we do believe we have the best control plane architecture, so we were not shocked about the results because of that.
Maybe just one question as well. So how does kind of Istio and kgateway play together or not? Is it like a full replace, or like obviously Istio has like probably a kind of like different scope in a way, or do they kind of like work together? Do I need to decide like what gateway implementation I want to use, either Istio one or the kgateway one? Like how do these two projects compare maybe and work together?
Yeah, that's a great question. So I'm going to continue share my screen then. I find out it's just so much easy to answer a question and share the screen. So we do believe kgateway and Istio can work easily together, especially in the ambient mode. Fabian, I think you're pretty familiar with the ambient. So we talk about ambient as layer 4 architecture, which is the zero trust tunnel, and the layer 7 architecture is the waypoint proxy. So kgateway can be easily plugged in as a waypoint into Istio ambient. So not only you can use kgateway as the ingress for mesh traffic or egress for mesh traffic, you can also using kgateway as a waypoint proxy in Istio ambient So we recently implemented all that in the kgateway project, where the zero trust tunnel can recognize the waypoint proxy is kgateway instead of Istio waypoint, and automatically route the traffic to kgateway waypoint before forwarding to the final destination. So I hope that helps.
Yeah, that's amazing. Yeah, very cool. I learned a lot today. It's definitely very nice to see these projects here explained a little bit.
Yeah,
No,
likewise. We learned a lot about vCluster.
Yeah.
I never thought, load balance IP was so easy, and I never thought kgateway works so easily in vCluster. So.
Thank you. Yeah, no, amazing. Really, really cool. Yeah, we'll definitely try it out also on our side. Maybe we can do even an integration like we did for Istio, right?
We would love
Yes.
to see that. Actually, I actually didn't know you guys publish vCluster and on Istio, because if you write any technical blog, we can help you cross promote them on whether on the Istio project or whether on the kgateway project or on the Agent Gateway project too. We would love that too.
Yeah, that would be cool. Like, yeah, can definitely make something happen there, I guess.
Yep, definitely.
Sounds
We'll write up something, and also we'll try to come up with some posts where you can have a single K gateway and how you can use that across multiple virtual clusters, so that you don't have to install the K gateway multiple times. So I think that's also something that is easily possible. But we'll kind of do the POC, the demo, and then write up something and then send it your way so that you can also promote that within the community.
Yeah, that would be awesome. We'd be happy to do that. Yeah.
Amazing. So thank you everyone for being there with us, and I hope you learned today about K Gateway. If you are already familiar with vCluster, or if you were not familiar with any of the projects, so you learned 2 projects today, vCluster and K Gateway, which is good. And I enjoyed the stream. Christian and Lin, thank you so much for hopping in for early morning Pacific time and doing a stream on K Gateway. I saw Christian was actually live even before the stream as well. So,
Yes.
so he's on the back-to-back stream kind of thing today.
Oh my gosh, Christian, how many hours did we put you to work?
I'm good. It was all good. It was good topics.
All right, cool. Thank you all. So a few things, make sure to subscribe to vCluster so that you do not miss the vCluster Fridays. We are coming up with a new open source project that we are exploring, learning about that, and trying it out on open source vCluster as well. And also do check out vCluster.com if you have any questions about multi-tenancy or the NVIDIA Scape kind of scenarios, or GPU sharing kind of scenarios. Then do DM us or join the Slack. Slack is for open source vCluster, and we would be happy to chat. Thank you all for tuning in, and see you next Friday with a different host.
Thank you so much for having us.
Thank you so much for having us. Yeah.
Thank you.